Hello, in this lesson, can we learn about the 6 most important rules in transformation? So the first one is about translation. So if you are taught to translate a given figure, for example, let's say this triangle, which is given by vertices A 1, 2, B 4, 2, and C 2, 5, using a certain translation vector, what that means is the hex coordinates here, which for example are 1, 4, and 2, will be sent to x plus A, where A is the first value of that translation vector. In our case would be 3, because our translation vector is 3, negative 1. And then B, now the y coordinates will be, this one's 2, 2, and 5 will be sent to y plus B, where B is the second value of that translation vector, and in our case is negative 1. So can we try actually this question applying this rule, and we try to write the coordinates of the new translated triangle. So can we first copy the coordinates of the original triangle on my board, where we have A as 1, 2, then we have B as C, B as 4, 2, and then C as C as 2, 5. And then the translation vector MB is 3, negative 1. 3, negative 1. So the rule applies that the X for to get translated, then B translated, let me put them like this, and then C translated. We need to apply this rule where all the coordinates of X, we add A, where A is the first value of the translation vector, and then the coordinates of Y, we add B, where B is the second value of this translation vector. In our case, is negative 1. Then we'll get the translated coordinates. So we can start with the first one, where we have a translated, and we already know we need to take x plus A, and x is 1, then A is 3, so 1 plus 3 will be 4. Then go to the y coordinate, where we have y plus b, and we already know y is 2, then plus b. B is negative 1, so 2 plus minus 1, it will be 2 minus 1, which is 1. Then we go to the second one, then be translated here. And then we start, of course, with x. X we know is 4, but now plus A, where A is 3. So it will be 4 plus 3, which is 7. And then we go to y plus b, and we already know y is 2. So 2 plus minus 1, which will be 2 minus 1, which is 1. And then we go to c, and we already know C, we have 2, 5. So the first one is 2 plus A, which is 3. So 2 plus 3, which is 5. And then the second one is 5, but we already know y plus b, of course, b is negative 1. So it will be 5 plus minus 1, which is 5 minus 1, and becomes 4. So these are the new coordinates of the translated triangle. So can we go to the next rule? The second rule is that it's about reflection on the x-axis. So if you are taught to reflect a finger on the x-axis, what happens is the x-coordinates of that figure remain the same, but the y-coordinates change to negative. So with that rule, can we try to solve a question here, where you are told a triangle as vertices A 2, 3, then B 5, 3, then C 4, 6, then that triangle is reflected in the x-axis, and you are to write down the coordinates of the image of that translated triangle. So as we said, all the x coordinates, like in this case, this is x, and this is x, they remain the same, but the y coordinates, this one, and this one, they change to negative. So then you coordinates for A and B, x remains, and now y changes to negative, and because it was 3 now, it becomes to negative 3. This is 2. Then we go to B, reflected. The coordinate for x changes, but now y changes to negative 3. And then we can go to the last one where we have 4 remains, but 6 changes to negative 6. And that's how we reflect a triangle or a finger on the x-axis. So then we go to rule number 3, where we have reflection on the y-axis. So when we are reflecting on the y-axis, what happens is the y-coordinates remain the same, but the x-coordinates change to negative. So can we try this example here, where we are told a triangle has vertices a negative 1, 4, B negative 3, 4, then C negative 2, 7, then the triangle is reflected in the y-axis. State the coordinates of the reflected triangle. So let me copy this ones first in my board. So the rule is all the x-coordinates change to negative, and then the y-coordinates remain the same. So if we need to get now the x reflected, it will be, you see this is negative x, and so of course all x coordinates should change to negative. This is x, this is y, this is x, this y, this x, and this y. So we start with this one. You see it was negative 1, but all of them need to change to negative, and you see it's already so negative. So if we multiply this negative by this negative, so it will be positive, and that's why now negative 1 becomes 1, but 4 remains like that. Then if we go to be reflected, the x coordinate should change to negative, but you see this negative x, we already have negative here, and the coordinate for x here is also negative, so it's kind of like saying negative multiplied by negative 3, this negative for the x, then multiplied by this negative 3, which will be positive 3 now. So this becomes 3, and the coordinate for y remains the same. And then you go to C, the same we have negative x, so that negative multiplied by this negative 2, which now will be positive 2, that is for C, and then the y coordinate remains the same. And that is the value which is about reflection. So the fourth rule is about rotation and 90 degrees clockwise about the origin. The origin is of course point 0, 0, and if we do so, then the rotation 9 degrees clockwise, the coordinates first change, the x coordinates become the y coordinates, and the y coordinates become the x coordinates, but now negative. So can we apply this rule to solve this question where we are told a triangle has vertices A31, B61, C44, and then the triangle is rotated 9 degrees clockwise about the origin. Then you are told to give the coordinates of the image or the coordinates of the translated triangle. So as we said, the coordinates x, y, they change to y, x, but now this x is negative. So from there, the first step from these ones, we can just interchange the coordinates. So I can say the n reflected will be the y becomes the x, and the x becomes the y. So it becomes 1, 3, like that. Then we go to be reflected where we have 1 starts, then 6, we interchange them, then we go to C reflected where we have 4, 4, but then we said all these ones here become negative, so we put negative on each of them, and that becomes the rotated triangle. So can we go to the fifth rule where we have rotation 90 degrees anti-clockwise about the origin. The previous one was clockwise about the origin. This one is anti-clockwise about the origin. So the coordinates still change from xy to yx, but now the coordinates of y are the ones which become negative. So can we try to apply this logic to solve this question, where we have a triangle has vertices A 1, 3, B 4, 3, and C 2, 6, and then the triangle is rotated 9 degrees and clockwise about the origin, and you are told to find the coordinates of the translated triangle. So the rule is xy changes to negative y x. So to get the new coordinates here, the first step is just we need to interchange them so that the x ones become the y ones and the y ones become the x ones. So in the translated A, now 3 will start as the x, and then 1 like this. Then we go to the second one where we have B translated. It will be 3, 4, we interchange. Then we go to C, translated where it will be 6, negative 2. No, sorry, will be 6, then 2, like this. And then from there, we put negative in the ones which start here, like this, so that it aligns with our y here, and that becomes the rotated coordinates of the triangle. So can we go to the last rule, which is rule number 6, and it's about enlargement. So if you are told an enlargement with scale factor k from the origin sense or the values or the coordinates of that figure to kx and ky, simply you are told to multiply all the coordinates with that enlargement factor or that scale factor, and we can apply that rule to solve this question here. Here we have a triangle as vertices A21, B41, and C33, and then the triangle is enlarged by the scale factor negative 2 from the origin, and then you are told to find the coordinates of the enlarged triangle. So let me first copy these coordinates in my board. So these are the original coordinates, and you are told the scale factor or the enlargement factor is negative 2. So the formula, of course, becomes kx, where we multiply all the coordinates of x with the enlargement factor, and the same will do to y, like this. Then from there, this is the x, this is the y coordinate, this is the x coordinate, the y, the x, and the y. So now, translated becomes k, which is negative 2 multiplied by x, which is also negative 2, and becomes negative 4. And then the next one becomes negative 2 multiplied by 1, which is negative 2. Then we go to b. Now enlarged becomes k multiplied by x, which is negative 2 multiplied by 4, which is negative 8. Then negative 2 multiplied by 1, which is negative 2. And then c enlarged becomes negative 2 multiplied by 3, which is negative 6. And the same for y, which is negative 2 by 3, which is negative 6. Like that. And that becomes the new values of the enlarged triangle. So this is the end of this lesson. If you have any question, if you don't understand anything in this lesson, you can ask me in the comment section. I try to answer my best. And bye for now. Let us meet in the next lesson.